Our first talk is from Jill Naiman, and she will be talking about Houdini and RHytHM.
So let me press play. Yeah, so I'm going to talk, as mentioned, about some work that is being done, including YT into the special effects software called RHytHM. And so the paper that I'm really focusing on this talk is by Tina Borkowitz, who couldn't make it this morning. She has a bunch of other meetings. So I'm going to sort of be in her stead. And sort of to a lesser extent, a paper we did before where we did just a few things of getting data to load into Houdini. I'm going to be talking about how we're supporting AMR in Houdini right now. And so again, I'm talking really about her paper. Also, these slides I basically just stole from Kalina, so that's why they look really nice. And also for this particular part of the project, most of the development was sort of done with Kalina, and also the student we were working with, Hao Ming, who's also on the paper. But you're getting a talk by me, so so apologies for that. I will try and do all of her work justice. Okay, so if we're thinking about sort of three broad bracket, or I should say two broad brackets of visualization, so sort of information visualization and scientific visualization. This work is sort of overlapping in scientific visualization, combining kind of analytical stuff, so stuff that historically YT has been used for, and also cinematic visualization. And so talking a little bit about cinematic visualization, this kind of brings together a few different veins of science, but also art, and then of course technology. And so to create a cinematic visualization, all of these are sort of equally important here to consider. And so this is the group that this work was done with. So this is the Advanced Visualization Lab. There's even a picture of Kalina there. And the group focuses on making a lot of publicly facing visualizations. And so here is sort of a list of a few things that they have done over the past years. And these are planetarium shows and also IMAX screenings and things like that. So I'm not going to go through the whole demo reel, but here are some things that may or may not look familiar to folks. Focusing kind of on the astronomy type stuff. They've also done stuff with beyond looking at astronomy stuff, looking at, for example, here is a little of, I think from the birth of planet Earth. So I'm not gonna, that's a really cool demo reel, but we're not gonna have time for it. I would suggest looking it up. So creating these kinds of visualizations is sort of a complex process because at every step you have to think about how your audience is going to see these things. And so often they don't use just pure scientific visualization tools to do this. So I'm not going to go through all of this stuff, but just you could take the away from it's a complex process. Okay, so typically though, they don't usually create their own software. And so right now they're using the special effects tool Houdini. Historically, they've also used stuff like Maya. I keep trying to get them to consider using Blender, so we'll see how that goes. I know some folks are working in Blender here as well. So a lot of these special effects tools are pretty good because they're made for making movies, but often to get it to sort of work nicely with scientific data, you have to sort of build out a middleware to translate the scientific data into these formats. And so that's sort of what this project is centered around. And so here is an example of getting some scientific data into Houdini. So this is just a quick volume running of a simulation, I believe, of a tornado. And so here, this is the Houdini interface. There's a lot of buttons. It sort of looks pretty different to how we would do things when we're programming with just YT alone. But again, this is software that people in the special effects industry use all of the time. And so here is that rendering that is made with the sort of quick volume rendering that I was showing before in the Houdini interface. So that's sort of what this looks like. And the rendering is being done with the Houdini's default rendering engine, which is called Mantra. So this is Houdini and Mantra. Okay, so the issue that we kind of run into with the majority of special effects software is that if you're doing volumetric data, things like Houdini and also Blender and also Maya expect your grids to sort of look very regular here. And the simulation that I was showing in that movie that was made actually has sort of an AMR-esque looking type of grid. So trying to get these things to talk to each other is sort of a little bit of a trick. So for most of the stuff that we're doing with YT, we're talking about work here that AMR, but of course YT is great at doing all kinds of different grids. So I don't think we've had a chance to do any grids that are more special in AMR, but something for the future that we can definitely work on. Okay, so what are we going to do with this complex data in the special effects software that's expecting regular grids? So we can try, for example, to force it into a regular grid. So the problem with that is either we're going to be sacrificing some resolution or we're going to have to sample it to its finest resolution. And of course, that's going to create a lot of extra memory issues. And so that can be, a big problem if we're dealing with some of these really large scientific simulations. I mean, the reason that AMR, well, not the entire reason, but one of the great things about AMR is you have this ability to not have to waste resources by having a super fine grid everywhere. So the other thing we could do is use a different software, but if we're stepping away from visual effects software and using scientific software instead, that can make things a little bit difficult as well. And so, on the special effects side, there's opportunities to use Houdini, Maya, Blender, but all of these have kind of the same issues with scientific data. And so she's got some slides discussing YT, which is a little strange given that this is a YT talk, but I do want to talk about it in terms of the issues that come up with doing some rendering with YT in kind of a cinematic context. So of course, YT is great at the AMR, so that's awesome. And so it does that sort of very easily. That's one of the things it was built for. It's open source. So Houdini is not open source. So that's something that we run up against. And so that's what's great kind of about using YT to do things. And YT has been used to do some cinematic visualizations. And so I think this is an example. I don't remember which Dome show this is from, but this is an example of how YT was used to render something cinematically. And what's nice about it also is that it can be used to create derived data products. And this is something that Houdini does not do very well. So you have to do kind of all of your complex data manipulations not in Houdini for the most part. But YT, of course, is really great at that as well. It also runs on supercomputers. So that's useful for rendering if you have to render something really, really large. And again, it's open source, so that's awesome. And so, but it doesn't really have the same special effect kind of GUI that Houdini does. And if you're working with, as they like to call them at AVL, the Renaissance team, where you have not only people doing with a scientific background, but also people that have a background in special effects and graphic design, this becomes kind of a problem because they're used to working with data in a very different way. Okay, so the other thing is that it can be a little bit tricky to get one or more than one, sorry, attribute sort of rendered volumetrically at the same time. And so I know that there's been updates for this in kind of ongoing work, so that's really exciting. But it's also hard to add a lot of sort of special effects type motion blur and lighting and all of these other things directly with YT. Okay, so sort of summarizing that, we've got some pros for both of these systems. So for YT, it's really great for data analysis, for efficient running on supercomputers. It's great with scientific data. It's also open source. And then Houdini, of course, is really made for artists. So it's very artist friendly. It can render multiple complex different kinds of geometry. It can easily do multiple objects in a scene. It's very easy to combine data sets. And then lighting and special effects tools are also available in Houdini. And so this was sort of the idea behind creating YTini. And this was the kind of second project we did. So first we got some just reading happening in Houdini using YT, and then we decided to tackle trying to get AMR to work in Houdini. And so this is sort of the, let's see if can I get both of them? I don't know if I have to click on one of them. Shoot, oops. Okay, well, at least you can see it in pictures. So this is sort of the default rendering if you try and render AMR in Houdini without doing sort of the special processing and special reading that we did. And so you can clearly see this AMR structure here, all of these blocks. And so that's not very useful. And then our final rendering with Whitini, doing some tricks both in data processing and also with a custom sort of rendering pipeline, not really rendering, but shading pipeline in Houdini, we can take all of those artifacts out. And so that's nice because now we can use these really large data sets that are AMR without having to do those memory wasting things of downsampling or upsampling to the finest resolution or downsampling and losing a lot of those details. Okay, there we go. So you can find out more at whitini.com. Since I have time, I'm going to actually grab that website and just show a few things you can look at, including our tutorials. But there's a really big caveat. I should have made the text here bigger below. So it's a little tricky to install. So I'll show our installation instructions, and you'll see that it's like very specific to different versions of Houdini. Luckily, we're hoping that this is going to change in the future. So right now, I think the current versions of Houdini only support up to Python 2. Of course, we know that's a problem. So I think the development version of Houdini, and hopefully that will be pushed to the sort of more user-friendly version of Houdini, going to support Python 3. And I think they'll also hopefully have a kind of more complete Python installation. So just a caveat on that. Yes.
Sorry to interrupt you. 5 minutes.
Thank you. Okay, so let me grab, oops. Just to sort of show off. So this is if you're interested in using any of this stuff. So we have, you can go to whitini.com. And so what's nice, of course, is working with an artist, right? We can get all these cool different visualizations that are very easy for them to make. So that's kind of fun. So just pointing out that, our Get Setup page, right? We have different versions here. And there's a lot of like tricky kind of hacky things you have to do to install stuff. I know people have tested it on Windows machines. I have some updates to the Windows installation that I have to put on the page. I'm just behind on everything. But you can see, for example, we're like reinstalling 6 and it's a little bit of a mess. So hopefully this is something that's going to be a little bit easier going forward. But just a heads up on that. If you are interested in installing this, we're happy to help you walk through it. Not a problem. So you can just send one of us an email. You can send me an email. Okay, but we do have some tutorials. So there's, if you don't want to go through the complex process of converting your data to use AMR, you can also just use YT directly to import data. And so this is a Python SOP, and so you can install this and it will actually load in data. You just have to point it to a data file. And so this is sort of our installation process, and then ultimately you get our, our good friend, the isolated galaxy. And then I think relevant to a talk that of course, the talks that I missed yesterday, I had to go to another meeting, but also using these sort of sparse data storage called VDB or OpenVDB. And so this is talking about installing VDB. I think if I remember correctly now, I don't know if it's in the development version of YT, but this might be a lot easier now with being able to export to VDB. But at any rate, we have some tutorials about how to do that, how to make some VDBs for each level of refinement you want to use in your AMR visualization in Houdini, and then ultimately how to read that in. So AMR data, so the entire process right here. So again, we don't have time to kind of go through all of that, but if you're interested, if that's something you want to do, or if you just want to play around with stuff, send me an email. Happy to kind of work through that. Okay, so I'm going to stop there and see if there's any questions.
Thank you,
I know
Jill.
it's first thing in the morning. Yes.
I said, thank you, Jill. Any questions for Jill? So raise hand feature and I'll call on you.
Let me see if there's. I got a cool. Oh, good. It's on your computer. I didn't see the chat. Sorry.
It's okay. I see Maxime, you can go ahead.
Yeah, thanks. Thanks a lot. I'm just wondering, what kind of machine do you need to render this kind of thing? Can you do that on your laptop, or do you need to absolutely install that on a supercomputer, which might be even slightly harder?
Nope.
Yeah, so that's a good question. So I will say all of the rendering that I've done with Houdini has been with their free version. And so all of this has at least been tested on my computer. If you are trying to render something really big, then you can, it's mostly a loading the data into memory kind of a problem. Of course, if you don't have, you know, a nice GPU, it might take a little longer to render things, but you can definitely do it on a laptop. So that really the rendering for that you run into issues where you might, you know, want to a supercomputer is if you're doing like a movie that has a lot of data frames or a lot of frames. And so in that case, I mean, it depends. If you can wait a while, you can definitely do it locally. Definitely some of the, I don't know if folks have heard of the CATS data set. It's the sort of collection of turbulence simulations that Blakeslee Burkhart has, but there's a little movie that we used Houdini to make. And that, you know, a friend of mine, AJ, who also works at the ABL, he did that on his local machine. So it sort of depends on it really depends on your data.
Cool, thanks.
Yeah, thanks.
Any other questions for Jill? Quentin.
Hey, really nice talk. I really enjoyed it. I was just wondering. I'm not sure I understood. Maybe I had a problem during your talk, so I didn't hear everything. But why is it coupled with Houdini? Are you directly exporting to Houdini, or is it just for the file format?
Yeah. So the coupling with Houdini is two ways. So either directly just using YT to load it and then depositing on a uniform grid, or doing some processing to VDB outside of Houdini and then importing that. So it's sort of a two-step process into Houdini. And so the reason we're doing that is because artists sort of are used to dealing with special effects software more than they're used to dealing with scientific software. And so this allows scientific software to sort of, I shouldn't say easily yet, because again, caveats, but more easily be imported and used kind of in the format it was intended, i.e. AMR, in Houdini without having to do a lot of extra processing. So that's the sort of motivation. So it's used for this particular group. And then we're sort of hoping that it will be more and more easy to use for other folks, other groups that want to use scientific data that do movie making and stuff like that. Yeah, so particle data is definitely possible with in Houdini. So it does have a way to import particle data, and then you can actually transform it into volumetric data. We aren't doing anything with particle data yet, but it's definitely on kind of our to-do list. So you can, if you, I forget the format that it's expecting, but they definitely have done that with particle data, for sure.
Okay. Thank you, Jill. And we will now.
All right, thank you.